A very good morning, students. Good
Good
morning.
morning, ma'am.
Am I audible?
Yes, ma'am.
Yes, ma'am.
So, uh, so today we will start with the new class for foundations of blockchain. I could see the many of you are from the previous TOC class also. So let us not waste time in introduction. So maybe some other time we will do that. I think final years also have some of you have joined. So now initially I'll just share with you the syllabus and the teaching plan. We'll just quickly go through that first, and then we will move on to the introduction section. Okay, I think you'll be able to see the teaching plan I'm presenting here. So, foundations of blockchain. In this course, we have totally 6 modules, and we are just going to this syllabus we have is very basic syllabus only. We are going to study only about the blockchain technology with the help of bitcoins, and also in the last module we also have some applications related to that. So in the first module, we are going to discuss about the basic concepts of blockchain technology and what is the history of blockchain and how it came into existence. And then the Bitcoin, about Bitcoin, how Bitcoins. So I hope you would have heard about this term Bitcoin in your social medias and several websites you would have, when you come across, you would have definitely come across this. So we are going to study how blockchain technology is used in Bitcoin, and then in the second module we'll study about the Bitcoin design, and here we will study about the concepts of cryptography. And since in this class we have both third years as well as final years, I'll try to give you the concepts of cryptography so that both of you could cope up with that, because I hope final years you have already done your course on cryptography, correct? Am I right?
Yes, ma'am.
Final years? Final years, any one of you is there?
Yes, ma'am.
Yes, so you have done your course on cryptography, and I hope you have gone through it in detail. So, third years, I think you are ready to study cryptography. So, let me, we will not go in deep in cryptography concept. What is required for this Bitcoin or blockchain technology, that alone we are going to discuss it here. Okay. And in the third module, we will discuss about the cryptocurrencies, and then we'll study about some of the classical and modern consensus algorithms. And in module 5, we'll go for smart contracts. I'm just reading out this. So one by one, we will check that. Okay. So now let me share the PPT. So we'll start with the module 1 with the basics. Okay. Okay. So we'll start with the foundations of blockchain, the introduction part. So before we move into what is blockchain and what is blockchain technology and Bitcoin and so on, first we'll start with the distributed systems. So why it is so? Okay. Why we need to know about distributed systems and what is distributed systems, and what are the challenges in this distributed systems and how it is related to the blockchain. Okay, so that we will just go through it, and then we will see what it is. Okay, so yeah. So why we need to study about distributed systems? Why we need to mention distributed systems here? Okay. So the thing is, blockchain at its core, we can say that it is a distributed system. Okay. And more precisely, we can say that it is a decentralized distributed system. So what is the meaning of decentralization, or what is the meaning of first centralization? See, when you want to do some transaction, okay. See, for example, if you want to send money to someone, what will you do? You will either send through a bank, okay, or you through some online mode you will send it, okay. So there is some third party present in between the sender and the receiver, right? So only then you will be able to do the transaction. So that is called the centralized system. So some central or the third party is available between the sender and the receiver. Whereas in a decentralized system, so there is no central authority. Okay, there is no central authority to monitor the things. Only the transaction will be happening only between the sender and the receiver. So this blockchain technology is a decentralized distributed system. Okay, so that is why we need to know what is this distributed system is. And so what this distributed system is that, so it is a network, okay, where two or more nodes are connected with each other, and they are connected in such a way that they try to achieve a common outcome. Okay? They wanted to achieve some common outcome, and say they work in a coordinated fashion. Okay, so that is what this distributed system is about. So when we, as an end user, when we look from outside, it seems like a single platform. Okay, but it is a network where several nodes are connected with each other, and they work in a coordinated fashion to achieve some common purpose. Okay, or to achieve a common outcome. So that is called the distributed system. Now, so what this node is, so what is this network, and what is this nodes are all? Okay, so each of these you can see in this picture. So there are several nodes connected, and we'll again look into this. So what is this node? Okay, so this each node, it can be an individual player. Okay, and for example, if you want to do a transaction, then it may be a sender and another node is a receiver. Okay, and when we study about the blockchain technology, okay, or the Bitcoin network, it is all systems. Okay, it is not a person, but it is a system. Okay, so like here, a node can be either an individual player, and all these nodes will be, they are capable of sending and receiving the messages. Okay, so each of these, so it is a network, and all the nodes were connected to each other, and they send and receive messages to each other. Okay, and now this what is the characteristics of these nodes is that they can be honest, they can be faulty, or they can be malicious. Okay, so what is the meaning of this? Okay, so so we will see with an example at the back, but now just you know that this nodes, so for example, when you do some transaction, you know that some third party may hack your transaction, right? So that node is also part of that network. So this node, it can be a malicious one also. So disrupting, they're trying to disrupt the process or the network. Okay. Now, so that is what called this Byzantine node. So a Byzantine node is nothing but it is expressing some unexpected behavior. Okay, so a node that can exhibit arbitrary, that is an unpredictable or erratic behavior, is known as the Byzantine node. Okay, and this such unexpected behavior, we call it as a Byzantine. Okay, so now what is this? Why they are doing so is, we have seen that in a distributed system, what is our purpose? All the nodes that are connected together in that network, they are working on a common purpose. Okay, they try to achieve a common outcome. Okay, they have to coordinate in a they should work in a coordinated fashion. Okay, so now in that network, there are some nodes which try to disrupt that common purpose. Okay, so they will work in they don't follow that coordinated fashion, or they don't follow that predictable way, and they go in some other unpredictable way or erratic way. Okay, so that is called as this that is why these nodes are called as Byzantine node. Okay, so what are the challenges in this distributed system? Um, so as we have discussed, there are certainly some nodes which will be malicious, which will be behaving in a unexpected behavior. So what are the challenges in achieving this distributed system? So it is the main challenge is that the coordination between the nodes. Okay, the coordination between the nodes. And the second challenge is the fault tolerance. Okay, you can see here. So the first challenge is coordination between the nodes, and then fault tolerance. So what is the meaning of fault tolerance? So even if any one node fails, the network should not fail. Okay, still it should be able to continue to work. Okay, so even if we find that some of the nodes are faulty or it is behaving in an unexpected way, so the network should actually work in a it should continue to work, and it should not get broken. Okay, so that is called the fault tolerance. Now so to make this happen, okay, to make the coordination between nodes and to make the system fault tolerant, there are several algorithms and mechanisms has been proposed in the past years, and this is an active area of research. And to overcome these issues, they are trying to bring out several algorithms and mechanisms to bring in a proper distributed system. Okay, so but they say that it is not so easy to design such distributed system without any fault, and so it is so challenging. And even they come up with a theorem. Okay, we call that theorem as a CAP theorem. Okay, we'll now study that. So using that CAP theorem, what they are trying to prove is that the distributed system cannot have all much desired properties simultaneously. Okay, so it is not at all possible that simultaneously we cannot have all the properties in the distributed system. So what are those properties and why it is not possible? Okay, so what is this CAP theorem says? So first we'll see who has introduced this. So this CAP theorem is also known as Brewer's theorem, because originally it is given by Eric Brewer, and then it is proved as a theorem by Seth Gilbert and Nancy Link, okay, in 2002. So now this CAP theorem, what it means is that for the three letters of the theorem CAP, it mentions that consistency, availability, and partition tolerance. Okay, consistency, availability, and partition tolerance. So what the theorem states is that any distributed system cannot have consistency, availability, and partition tolerance simultaneously. Okay, so it is very challenging to design a distributed system with all these three qualities working simultaneously. Definitely, if there is consistency, availability will not be there. If there is availability, tolerance will not be there. Okay, so there is one thing will be missing, and all three qualities or all these three characteristics will not be present in a distributed system simultaneously. So that is what they are trying to prove in this CAP theorem. So we'll look into it one by one. What is this consistency, and what is availability, and what is partition tolerance? And this consistency, so it is a property that ensures that all nodes in the distributed system will have a single latest copy of data. Okay, so what is the meaning of that? We have several nodes and in the network, and we are passing on the messages between the nodes. Okay, because each node is capable of sending messages. So once you send a message to another node, all the nodes should be revised with the new data. Okay, so all the nodes should have the recent copy of data or the single latest copy of data. So otherwise there will not be consistency. But you see that how difficult is that. Okay, so in a network there may be some 1,000 nodes or 2,000 nodes. Okay, any number of nodes may be there in a network. So once you do a transaction to a node, that has to be replicated in all other nodes in the network, so that there will not be any inconsistency between the nodes. Okay, so that is what we have seen, that what is the challenge in the distributed system. Okay, coordination between the nodes. So once you do a transaction between any two nodes, the that transaction has to be updated in all other nodes also. Okay, so the coordination has to be done among all the nodes, and so that is the meaning of consistency. And the second letter of the CAP theorem states that it is availability. So what is the meaning of availability is that the so all it should be available. Okay, the meaning of availability is the system should be available at all times. Okay, so it should be accessible for use and is accepting incoming requests and responding with data without any failures as and when required. So that means it should be available all the time. The system should be available all the time. Okay, there should not be any failure, there should not be any problem. All the time it should be available. So that is also not possible all the time. Okay, so the next third property of that CAP theorem is that partition tolerance. So what is the meaning of partition tolerance? So here it ensures that if a group of nodes fails, but still the system should be able to operate correctly. Okay, so that is the meaning of partition tolerance. So there are some 1,000 nodes in the network. Because that some one or two nodes got broken or some issues is that the system should not fail. Okay, but all other systems or nodes in the network should be still continue to operate correctly. Okay, so this is the partition tolerance. So now we have these three properties: consistency, availability, and partition tolerance. So now what they try to prove with this CAP theorem is that in a distributed system, it is definitely not possible to have all these three properties simultaneously. Okay, so that is how this distributed system is so challenging to design. So why we are discussing about this distributed system? Because as we are moving on to study about blockchain technology, and since blockchain technology at its core, it is a decentralized distributed system, we need to know the we need to know what is distributed system and what are the challenges in distributed system. Then only we will know how it is applicable in blockchain technology also. Okay. So so now we have seen that that we need to have the fault tolerance or the partition tolerance. Okay, so how we can achieve that? So in order to achieve the fault tolerance, they are using the concept of replication. I hope you know the meaning of replication, right? So so usually, for example, if you have your password, okay, if you have your password for any because nowadays passwords are common and you use it for all purposes. Okay, starting from your email account for your bank account. Okay, so for everything we are asked to give a password. So if you're going to have your password in only one, maybe so you assume that you will forget your password, so you write it down in a notebook, or you have typed in a notepad and save it in your system. Okay, so that is the only place you have stored your password. But if suppose, okay, if your system corrupts, okay, and all your files have been crashed, or the paper or the notebook in which you have written the password, it is lost, okay, then what happens? So then if you forget your password too, okay, then what happens? Then you will not be able to recover certain things. Okay, so maybe for an email or things like that, you will be able to you can give forget password and you can change the password. But when you are going to study about blockchain, you will understand how important it is to keep those things important, because once lost, it is ever lost. You will not be able to retrieve back anything. Okay, so that is why to achieve this fault tolerance, replication is used. So the replication means then you are storing your that same data in different places. Okay, so that is why if one system fails or if one node fails, then you will be able to retrieve that same data from another node, from another place. Okay, so replication is used to achieve the fault tolerance. And then consensus algorithms. So this consensus algorithms is used to achieve the consistency property. So what we have discussed about consistency in all the nodes, so whatever change you have made to a data in one node, that should be available in all the nodes. Okay, that should be reflected in all the nodes. So only then your data will be consistent. So now this consistency can be achieved using some of the consensus algorithms. So we will discuss about these consensus algorithms in detail in the later classes. Even in the next class, we will have some of the things about the consensus algorithm. Okay, so that will help us to ensure that all the nodes in the network will have the same copy of data. Okay, so you might have even study in your database or somewhere, like when you do a transaction, so the whatever the details that you have done, okay, you might have initially in your account you will have 1,000 rupees, then you do the transaction of 500 rupees to another account. So here it should be the balance should be 500, right? Now this transaction, what you are doing, it should be replicated or should be reflected in all the nodes in the network, so that everyone will know what is your current balance. Okay, so this kind of consistency, it can be achieved using the consensus algorithms, and we'll study about some of the consensus algorithms in this course. And we can call it as the state machine replication. So why we are talking about all these things is that in blockchain, this is very essential. Okay, this property is very essential in blockchain. So we have talked about that some of the nodes can be faulty or it can be malicious and so on. Okay, so what are the main two types of faults that a node can experience is that one thing is a faulty node, it can simply crash. Okay, a node may simply crash. Okay, and another type of fault is that a faulty node can exhibit malicious or inconsistent behavior arbitrarily. So we have already discussed about that, right? So in a network there are several nodes, and in a distributed system what we expect is all these nodes should work in a coordinated fashion to achieve the common outcome. Okay, but then if there are some faulty nodes, okay, that means the fault, one thing is a node may crash. Okay, it for some reason the system may crash and the node was not useful then. Okay, that is, the link is broken from the network. And another thing is, it is intentionally malicious. Okay, they want to corrupt the system, and they try to they try to exhibit some unexpected behaviors. Okay, not in the coordinated fashion that all the other nodes were behaving. So these are the two different types of faults that may occur in the network. So we'll see one example for this. The general example for this is the Byzantine generals problem. So what is this Byzantine generals problem is that, see now, this has actually happened in the some years ago. Okay, so what it is actually is that there was an army. Okay, there is an army called Byzantine army, and so they wanted to attack a particular city. So in that army, they have several commanders, or the generals, we can say. Okay, the commanders in the army. So now they were all in different places, and they need to communicate the message properly, that if the army needs to attack the city, then the message has to be passed on correctly. Okay, so all the generals present in different places have to be given the message properly, so that all the soldiers in different places will together go and attack the city. So if the commander says attack, that message has to be passed on uniformly to all the generals and down the line to the soldiers. Okay, that is the procedure. But now there is a possibility, there may be one or two generals who act against the army. Okay, that means what is that? They are acting supporting the enemies. Okay, so what happens if the commander says that attack this one general alone? He will be passing the communication that no, we should not attack now. Okay, then what happened? Only few of the soldiers will be going for attacking the city, and definitely they will fail to achieve what they are trying to do. Okay, and when the commander says that do not attack, now if he is going for attack, that is also a problem. So we can see in this picture, the nodes one with the stripes is the traitor. Okay, because they are acting against the army's commands. So that may be a general or the lieutenant, or the commander himself may be a traitor. Okay, so in such case, the information that is passed, it will be it is not passing on to the it is not passing on to the nodes properly. Okay, you see here the on the second picture, you can see here. So one is that all are moving towards the city in one accord, and they are attacking the city. Okay, and in another, the second picture, some of them are moving forward towards the city, and some of them are reverting back. Okay, then what happens? They will not be able to achieve the outcome that they need to do. Okay, so this is the Byzantine generals problem. So I think now you will be able to understand what is that a distributed system is. Okay, so it is the paradigm where all the nodes should work together in a coordinated fashion to achieve a common outcome. So here the common outcome is to attack the city and destroy the enemies. Okay, so for this, each node is a general under whom several soldiers are there. Okay, so if the commander says attack, then all the generals in that who are hiding in different places should get the same message of attacking the city, and they should go together. Okay, otherwise they will fail to achieve that. So if there is one faulty node, okay, if there is one node or the one or one general is traitor, then he will give some other message to the his soldiers. Okay, so all now the messages were sent through a particular person, and he may also act as a traitor. So all these things. So this is the problem they find out in the army. That is why this is called as a Byzantine general's problem. Okay, so that Byzantine army is mentioned here as the Byzantine general's problem. And so now in any of our application in the networks that we have, the same kind of problems may occur. Okay, some of the nodes may behave as a faulty node or a malicious. So malicious in the sense they are intentionally doing that, okay, to disrupt the network. So that is why it is told that even if one of the node is failed, okay, even if one node is faulty and if it fails, or if it tries to behave maliciously, then also the system should work properly. Okay, so that is what fault tolerant system. And another challenge we have seen is coordination among the nodes. So the message that is passed between the nodes, it should pass really correctly between all the nodes. Okay, so now so as we move on towards the course in blockchain, we will see so how this distributed system is applicable in a blockchain, and how it is related with that blockchain technology. And we'll see using how tomorrow in the next class we will see some of the we'll see the concept of consensus algorithm. Okay, here we have seen that algorithm is used to achieve the consistency. Okay, so whatever the data that you are passing on to different nodes, it should be reflected in all the nodes. Okay, so that is when there will be consistency. So we will see the concept of consensus. Okay, that means they all should agree, okay, upon something. Okay, so how they are agreeing upon a certain thing, what is the mechanism used to communicate things between the nodes, how the coordination is done. Okay, all these will come in the consensus algorithms. So with this, let me stop this session. We'll continue with the consensus, and then we will move on to the blockchain. So how this blockchain came into existence, how this blockchain technology came into existence, and then we will talk about the bitcoins and so on. Okay, do you understand? Can I get some answers
Yes, ma'am.
in the chat box too? Yes, are you all here?
Yes, ma'am.
No, no response in the chat box. 1 or 2 only responding. Okay, okay, students. So we'll let me take the attendance. Please unmute your mic and give your attendance. URK 18CS038, Neela Sumant. Please unmute your mic. Neela Sumant is present. He's not there. 85, Jomin Jos.
Present, ma'am.
Yeah. Manoj Preetham. Manoj.
Present, ma'am.
Yeah. 180, Jerome Andrew. Jerome. Jerome is not there. Nelson Darius, 193.
Present, ma'am.
Yes, Nelson, I think you're trying to say, but I couldn't hear.
Present, ma'am.
Annie Verghese, your mic is not working. Please put it in the chat box if you're present. Annie Verghese,
Yes, ma'am.
yes. Sheshandri, yeah, Nelson Darius present. Gemini Annie Verghese present. Sheshandri is there? Sheshandri Kumari. Annie Cruz.
Present, ma'am. Present, ma'am.
Yes, yes.
Ma'am, 1068 is
Then,
also present.
yes, what, ma'am?
York and 19 says 1068 is also present.
Yeah, I have not called you yet. Wait.
Oh, okay.
Venkata Mukesh.
Yes, ma'am.
Naveen Kumar. 260 Naveen Kumar. Yeah. Preetham 1001. 19 CS 1001.
Present, ma'am.
Galadi Preetham.
Oh, present, ma'am.
Then 1007 Benzam Raj.
Present,
Benzam
ma'am.
Raj.
Present, ma'am.
Okay. Angeline Subagar.
Present, ma'am. Present, ma'am.
Is it Angeline, your name?
Yes, ma'am.
Okay. Ujjal Amitya
Present.
Victor.
Present, ma'am.
Okay. Pragada Laswita.
Present, ma'am.
Joel Sam.
Present, ma'am.
Yeah, after the class, after taking attendance, I'll share the GCR code. Steve Abraham.
Present, ma'am.
Aditya.
Present, ma'am.
Devin.
Present, ma'am.
Saumya.
Present, ma'am.
Adina.
Present, ma'am.
Joseph Rajan.
Present, ma'am.
Karen Beulah. Present. Divina.
Present, ma'am.
Alex Kuriakos.
Present, ma'am.
Bharat.
Present, ma'am.
Ashish Kumar.
Present,
Would be good if you enable your video and give your attendance, because so that I could see you. Some of you are new apart from TOC class. Emmanuel Raja, enable
Present,
your
ma'am.
video, and Jabez Samuel Jayapandian,
Present, ma'am.
Sam Jonathan,
Present, ma'am.
Vigneshwar,
Present, ma'am.
Chinmuan Lal,
Yes, ma'am.
Letitia Maraklin,
Present, ma'am.
Ashley John,
Present, ma'am.
Hayden Rex,
Yes, ma'am.
Jemima Elizabeth,
Present, ma'am.
Arsha Anna Daniel,
Present, ma'am.
Rajat Nair,
Present, ma'am.
am I correct in pronouncing your name?
Yeah, ma'am.
Rishabh Nair,
Present, ma'am.
Manoj Abraham,
Present, ma'am.
Bibia Susan,
Present, ma'am.
GB Thomas,
Present, ma'am.
Selva Mabisha,
Yes, ma'am.
Abhilash, Abhilash is not there. 1145. Okay, Genovin Jabadas. Genovin is not there. Darwin.
Present, ma'am. Genuine present, ma'am.
Present, ma'am.
1145 present. Okay, Darwin is there?
Present, ma'am.
Okay, Lamek Vedaraj,
Present, ma'am.
Maria Santosh,
Present, ma'am.
Sasidhar Reddy,
Present, ma'am.
Austin,
Present, ma'am.
Sanjay Ratnam,
Present, ma'am.
Kevin Paulson,
Present, ma'am.
Kevin Paulson,
I'm here, present. Present.
yeah. Sri Sai Rahul Reddy,
Present, ma'am.
Kavin,
Present, ma'am.
Singham Shetty Johnson, yeah, present. So the absentees are 38. I'll put it in the chat box.
1164 is present, ma'am.
1164 present.
Yes, ma'am.
Okay. 38, 180 to 112 is absent. Okay, thank you, students. You may leave the class now. We'll meet in the next session. Thank you, students.
Ma'am, GCR code.
Yeah. I have given the TCR code in the chat box. Those who are yet to join the Google Classroom, please note down that.
Thank you, ma'am.
Yeah, thank you, ma'am.
Thank you, ma'am.
Yeah.